So this is a quick example to illustrate the relationship between current flow and charge. So we will recall that current flow, which we designate with the letter I usually, the definition of this is equal to the total charge, which we designate as Q, divided by the total time that we're talking about, which is T. And so these have units of coulomb per second. So charge is coulomb, time is in seconds. And this, by definition, is an amp or an ampere. And so that's the way our units work out. Okay, so in this example, they've told us that we have a total current flowing in our wire of 5 microamps, which we could measure with a meter. And so we want to use this information to solve for a couple of time frames. So in part A, we see that they tell us they want us to calculate the total charge in coulombs that travels through our wire with this 5 microamps over a time period of 10 seconds. So that being the case, we will need to utilize this equation here that we defined for the relationship between charge and current. And so to do that, though, we're going to need to solve this equation for charge, because that's what we're looking for in this equation. They want us to determine what the total charge is. So in this equation here, the total charge is expressed as Q, so we need to solve for Q. So to do that, we multiply both sides of this equation by T, or time, and when we do, we come up with the resulting equation of Q, which is our total charge, is equal to our total current multiplied times time. So this is the equation we can use to solve this part A. So in part A, again, we're told we have 5 microamps, and that's going to be times our time, which we said was 10 seconds. Well, we need to keep in mind that micro, this right here, symbol means 10 to the minus 6. So utilizing that, we rewrite this as 5 times 10 to the minus 6 amps. That's going to be times 10 seconds. So when we multiply that, plug it into our calculator, or however we want to do it, we should come up with 5 times 10 to the minus 5 coulombs. So this is the answer to part A. And now we need to move on to part B. So in part B, it's a similar request, but this time we're giving a time period of 2 years, which we see right here, 2 years. Okay, so we need this in seconds, though, not in years, because our equation is defined in seconds. So to do that, we'll take 2 years, and we'll start by eliminating units. So we know that there are 365 days in 1 year, so years cancels out. We also know that there is 24 hours in 1 day, so our days cancel out. And then we know that there are 60 minutes in 1 hour, so that makes our hours cancel out. And finally, we know that there are 60 seconds in 1 minute, so our minutes cancel out. So after canceling out all the units, we should be left with seconds. So we could rewrite this then to say that our total time is going to be 2 times 365 times 24 times 60 times 60. And that'll all be in seconds. So if we plug that into our calculator and calculate it out, we should come up with an answer of 6.31 times 10 to the 7 seconds. And so this is how many seconds there are in 2 years. So now that we have our time in the right format, we can go back to our original equation, which is Q, total charge, is equal to our current times our time. So in this case, we recall from before that our current is 5 times 10 to the minus 6 amps, and our time is 6.31 times 10 to the 7 seconds. And we put that in our calculator, calculate it out, and we should come up with 315 coulombs. So this is the amount of charge that would travel through our wire over 2 years.